Yep. So let's going to start. So today this session is all about the Project Bicep. So which is the ARM is as a resource management. It's a pun of the ARM. So we are going to use Bicep. So my name is Justin. I'm working for the Microsoft as a senior cloud advocate, and I used to work for AGL before joining, just before joining Microsoft. So as a contractor. So this is my Twitter and the GitHub handle. So if you like, you can just mention me. Then I'm happy to answer anything I know. So let's go. So this session, I'm going to run this session for about an hour, and I will keep my talk things as brief as possible, and then I'm going to show how the Bicep works as a demo. So as you know, why do we introduce the Bicep? Because the ARM template was, ARM template is a very great tool, but it's fairly hard to learn because many entry-level DevOps engineers start learning, so it has a very high the learning curve. So in order to lower the entry bar to ARM template, so that's why we introduced Bicep. And also the Bicep is a kind of declarative ARM DSL, so domain-specific languages. So basically it works the same, but it has a different expressions. And it sits on top of the ARM template. So it provides us with a transparent abstraction over ARM. So once we write Bicep files, and it can be easily compiled or built to the ARM template, so which is really fine for us. So that's why we called the project Bicep. And currently, the current version is the 0.1.37, which is still alpha, and meaning not production ready yet. But end of this year or early next year, that will be going up to version 03, which will be production ready. So for now, even if I'm introducing Bicep files for yourself, and you can play around inside your company, but I wouldn't recommend to use the Bicep files for your production yet. And currently, because it's still on the alpha version, so we can build Bicep file and convert into ARM template very easily with Bicep CLI, but we can't do it in the other way around. But after the version 03, and that will be supported as well. So we can, what I'm trying to say is we can convert from Bicep to ARM template, but we cannot convert ARM template from ARM template to Bicep yet. Then with Bicep, and we if you have used the Terraform or something like that, it looks very similar. So ARM template is it's a big JSON file, and it's very restrictive. So we have to write the parameters in the certain section. We have to write the variables in the certain section. We have to declare the resources in the another section. So we can write it outside the designated section. But with Bicep, there's no restriction. So we have much more freedom than ARM templates in terms of the writing or authoring. And also, if we write up Bicep and during the compilation to the ARM template, then it performs the basic the syntax validation while compiling the Bicep file. So we can instantly find out where the problem is, where the issue is. On the other hand, ARM template doesn't provide us with any sort of a syntax validation. So these kind of things is good for us. And so Bicep is cross-platform support. So regardless which platform you are running on, like a Windows, Mac, or Linux, every platform can be supported through the Bicep. And there are two things you need to install. For example, the first one is Bicep CLI, and the other one is VS Code extension. So yeah, I don't think Visual Studio is actively supported yet. But if you use Visual Studio Code, and there is a manual installation for this Bicep extension, and all the details for the extension and all the details for installation method can be found in this link, aka.ms/agl/bicep install. So visit there, and you can install both Bicep CLI and VS Code extension. So how to use Bicep then? So as I said, it's a DSL of ARM template. So basically, ARM template has a few sections in it. Currently, Bicep supports these 4 sections: parameters, variables, resources, and outputs. So parameters, if we want to use parameters, and yeah, this is how parameters look like. So see, we always start from param, then name, parameter name, then parameter data type. So for example, parameter name string, and actually that's it. That's basic form. And usually, if we make some description for each parameter, so we usually use metadata and description inside the parameter, one parameter thing. But we don't need to use that anymore. Instead, we just simply use the comment thing, / comment. Then it actually gives the description of Bicep file, Bicep parameters, right? So once we, so what does that mean? Do we still need to have the metadata or description within the ARM template? Actually, we don't need, because the ARM template from Bicep is a kind of IL, the intermediate one. So we don't actually need to look into ARM template anymore once we got the Bicep file. So we don't need metadata or description thing, just simply use comment. Then yeah, every parameters we can describe that in that way. Also, if we want to provide a default value of each the parameters, we can just simply use equal sign and they assign the default value like that. So for example, in here, param location, which is a string type, and it can have the location of resource group, something like this. And the next one is we are going to how we can provide predefined values, such as like an allowed value thing, which allowed is the equivalent to allowed values. So for example, in here, like the storage account skew thing. So param skew string, and it has these 2 allowed values, standard underscore LLS, standard underscore GRS. And its default value will be standard underscore LLS, something like that. So there are 2 different ways of providing default value, like string equals resource group that location kind of things, or explicitly declare what the default value will be in the SQ thing. So yeah, you can choose either one. So this is how the parameters look like. And the second thing is the variables. So variables is basically, yeah, the variable, and there is no data type, basically is the object type. So we start with var and variable name, and in that variable, we basically assign the object, such as like this, or we can either we can assign string or the number or whatever. Yeah, so, but usually we assign the object like this. And so within the Bicep file, we can, the Bicep file support string interpolations like this. So we don't need to use, like from now on, we don't need to use concatenation or format function anymore. But so concatenation can be very simplified with this string interpolation syntax like this, right? And then within another variable, so within another variable, we can reference to the other variable like this. So service plan can have a reference to the metadata long name, something like this. And in here, we can use the existing ARM template functions like formats or something like that. So format the existing metadata dot long name, and we change that the what is curly bracket with CS plan or something like that. And also when you see the location here, the blue location thing is from the parameter, and the yellow location is defined within the variables. So we can freely reference from the parameters and from the other variables like this. Okay. So this is how variables working. And this is how we are defining resources. So start with resource and resource identifier, then resource type. So for example, this is the app service plan. So Microsoft.web/server farms, and @sign after @sign is an API version. So we need to follow this this format. So resource identifier, and resource type @API version. Then an equal sign within the curly bracket, and we put everything we want, such as name is service plan name, and location is location, and SKU is something like that. And also, if we are defining a function app, then we need to have the consumption plan like this. Then when we define the function app, then yeah, basically they follow the same thing, but we don't need to worry about the resource dependency. When we write ARM template, then we have to explicitly put the depends on the properties so that we during the deployment time, the REST API understand which one goes first and which one can be deployed in parallel or something like that. But within the Bicep file, that kind of dependency is automatically resolved by referencing the CSPlan.id or CSPlan or something, CSPlan.name or something like that, because CSPlan is a resource identifier we defined already, and from there we can get ID, we can get the name, we can get other properties, something like that. So basically, by doing so, that function app resource has a dependency on the consumption plan by declaring in this way.
So just a small question. Like, is there any documentation from what are the output parameters that we will be getting out from a particular resource? Like, for example, in app service plan, whether it will be the app service plan name or the ID or something like that? Or
so basically, this is how we can. So when you're declaring the ARM template, we can also get the outputs from each resources, right?
Right.
Yeah.
But there we specified, right, in the outputs that we want to get the ID and name or something like that. But here we are not specifying anything, right? In the output.
Okay. So even if we are not specifying anything, during the compile time, Bicep will automatically resolve it.
Okay.
So that's the very easiest part, the easy part of using Bicep.
And if you go to the previous slide, please, second question I have is that the resource in the resource we are writing that Microsoft.web/server farms at something. So does it support the preview version of the APIs as well?
That's right.
Okay.
So as long as we the API, so each resource has different version, different set of versions, yeah, API versions. So you need to understand. Okay, so that doesn't really matter, which is regardless is a pre. You can use it.
Okay.
So any questions? Okay, so this is the output. So output, the syntax is very similar to the parameters. So output the name, the output name, then output the data type, and we can get the host names assigned into the Azure function app, such as like a function app properties and host names, such as like this. So yeah, that's how those 4 different the basic sections work, like the parameters, variables, resources, and output. So with these things, with these things, we can use the Bicep files. And for now, at this stage, the version 1 stage, we don't support condition, we don't support loop, we don't support copy. So if you are heavily relying on these 3 things, like conditions or copies or looping kind of things, and yeah, Bicep is not ready yet. So yeah, think about that. And another one is the ARM test toolkit, which is we usually call the arm-ttk. What it does is the ARM template linting tool, because we are writing Bicep files. We are not directly using ARM template, right? So, and as I said earlier, during the compile time, the Bicep performs a basic syntax validation, but it doesn't mean even if the ARM template is successfully compiled and generated, it doesn't mean it will work properly or not, right? So, and if you and another concern is that if you are using very old version of API of the particular specific as a resource, then they may have some sort of security concerns or something like that. So in this case, once you create Bicep file and run this arm-ttk against your generated ARM template, then it will run all the tests and show you which is good or we need to improve or something like that. So the usage of ARM template is to validate alpha's intentions. So for example, if we declare some sort of parameters, but we have never used that within the ARM template, then we don't need it actually. But ARM template is too big and complex. Sometimes we miss it. We remove those omit these kind of things. But if we run arm-ttk over that ARM template, actually it picks up these parameters or these variables has never used. So you can safely delete it. Okay, that's good. These kind of things can actively detect it for us. Also, sometimes output the values, maybe sometimes output values actually they returns us with very security the tokens or something like that. So running arm-ttk actually prevent us from returning those kind of values. So it's also good for applying us to good for us to apply these kind of security best practices. Right, too much talk. So I will show you about how we can generate or build a Bicep file and then run the arm-ttk over the generated ARM template. And the scenario will be we are going to create the Azure Functions instance. So in order to create Azure Functions instance, we should need at least 4 things. 3 things, I think. So first one is the storage account. Second one is consumption plan. And third one is a function instance. Maybe the application inside can be maybe an optional. So these 3 or 4 things will be declared within the Bicep files. Right? So I will show you. Oops. All right. So Azure deploy .bicep. So I create as a deploy.bicep file, and I have already installed both Bicep CLI and within the Visual Studio Code, and I also installed the Visual Studio Code extension, and also I installed arm-ttk in my my machine. So yeah, I can show that. So if I create, nothing. So I create a bicep file, and inside that nothing. There's nothing. But if I run this bicep file, compile the bicep file into JSON, it actually builds like this. Let's deploy that JSON with the skeleton structure. So, and here, let's start from the beginning. So I'm going to resource name, so param name string. So this is the resource name, the common resource name of entire the Azure function related instance, and also param env string, then allowed such as dev staging production, something like this, and maybe default value. If we don't provide any value to the env parameters, then it goes into dev. So what else? Param location string and resource group location. And what else? Okay, param location code string. Maybe it can be allowed, such as AUSE Australia Southeast or AUE Australia East, and default will be AUSE. So basically what I'm doing is kind of to provide resources with basic the naming conventions. So we don't need to worry about, but usually in within the AGL or other companies, they have their own like naming conventions. So I'm just assuming and the AGL is following the similar naming conventions like this. And also yeah, these are just naming related thing. And also I'm going to create the storage account related parameters. So param storage account SQ and string standard LLS and param storage account. Nope, that should be fine. And what else? Storage account. And what else? And consumption plan param. So do we have any consumption plan related things? Okay, so yeah, I don't think we have any declaration. So and what else do we have? Param function app. Do we need anything in here? Okay, I don't think anything in here. Then so we basically created all the parameters here. Now we are going to use we are going to declare the variables metadata. Here long name maybe in here. So what do we have? Okay, name, environment, location code. So name, environment, location code, and oops. And we can't use those hyphens within for storage account or storage account. So in this case, we just use short name without hyphens. And here, storage account, or so we get this. Now I'm going to declare the storage account. So storage account. So resource and resource identifier, I use just st, then Microsoft dot storage account at the latest one is 2019-06-01. And here name can be metadata short name, and location can be location. That location comes from here, right? So, and location, and what else? Kind, second generation of storage v2, SQ, name, what's the name? What did I do? Name to storage account SKU. Okay, SKU, and yep. What else? And consumption plan, and we also resource CS plan. And what is the consumption plan? What is consumption plan? What is consumption plan? Okay. Microsoft Web Server Farm at. So the API, I provide the API version like this. Name can be metadata long name, but we probably need to replace this placeholder. So format with st, and here format CS plan. Then location is location, and SKU is name should be Y1, and here should be dynamic. And what is properties? Okay. Name, that service plan name, then compute mode should be dynamic. Okay, so I will just stop here. So what we are going to create is two resources. One is storage account, and the other one is consumption plan. So I'm not going to add the Azure function app for now, but I will add it later. So by doing so, I created Azure deploy, and so I wrote the file onto the Azure deploy.bicep. And currently we don't have any compiled version yet. So once I finish it, I will decompile this the bicep file into a JSON. And here I create it, so it automatically generates everything. So it goes into the parameters and environment variables for within the parameter, and location code as well, and storage account is SKU. And within the variable section, I declare the metadata thing, so long name and short name. And within the resource section, I created the storage account with this API version, and I created consumption plan with this API version, or something like this. So this is how we create how we use the Bicep file to generate as a deploy, ARM template, right? And here now function app. I'm going to create a function app, resource function app, and that Microsoft web site at what is that? Hang on. Okay, 2020. Like this. Now name. So I just copy these two things in here. Oops. And here, instead of using CS plan, I'm using func app. Now location. Then what else? Kind, because it's a function app. So I need to put the kind here. And properties. So server farm ID, and server farm comes from this plan. So CS plan ID. And can you remember, by doing so, it automatically resolves the dependency between CS plan and function app. Right? And what else? Another one. Yeah. And here, HTTPS only true, and what else? Always on true, and site config. Within the site config section, app settings section. Within the app settings section, what do we usually put there? Usually we have the Azure Web Job Storage. we need to connect as a function into the storage account. So in here, name Azure Web Job Storage, Azure Web Job Storage, and here value. Oh yeah, that's the hardest part. So I'm just copy and paste here. So that's what I'm doing. So it actually gives the storage account connection string. So default endpoint protocol HTTPS account name is storage account name. So by doing so, the function app actually has two dependencies in this example. One to consumption plan and the other one to storage account. So by doing so, st.name, it automatically resolves those two dependencies. In here, to dependency on consumption plan, and with this dependency on storage account, right? And here, so yeah, and storage account ID, and I don't want to, so this list keys is basically the ARM template function, and get the storage account key like this, right? And what else? What do we have? Yeah, so basically it. So yeah, we can put as many the environment variables here as we can, but yeah, for now I'm going to stop here. Now, oops. I put another, so I compiled again of the Bicep file, and it actually shows the server farms and the function app as well. And when you see that dependency here, so I didn't explicitly set any dependency on here, but I put the CS plan ID. CS plan is a resource identifier, and ST is another resource identifier. So I just simply use that the resource identifier, and with these things, it actually put dependency in here like this. So without Bicep, we have to manually use these dependencies. Otherwise, sometimes if we forget dependencies in here, then maybe there might be an error, or because sometimes every resource is deployed in parallel unless we put the dependencies. So yeah, so that's how we do it. Now we have, so we only what we did is only writing the Bicep file, and with the Bicep CLI, that ARM template is automatically generated, so which is good. Now we don't. If I put some error in here, which part should I get an error? Yeah, such as okay, I put some typo intentionally, then it says error like this. So it basically checks the it checks the basic syntax validation. But as I said, it doesn't mean even if that generated ARM template is syntactically correct, it doesn't mean it's okay to use. Right? Even if it's okay to use, it might have potentially have some sort of vulnerabilities. So how do we ensure this is the healthy, the generated ARM template is healthy? Then the arm-ttk, we can use that. So in here, test ARM template and template path, and here, yeah, we use that. So if I use in this command, test dash AZ template, the parameter is test template path. It always looks for the old the generated the ARM template. So in here, if I do that, so it shows. Oops. Okay. I probably run this sometime again. Okay. So it runs this kind of test against my ARM template. So it says, yeah, depends on best practices. So it applies all the things. But if I say, if I have something like this, so more than 2 years old, if I use the API version more than 2 years old, then it built successfully, right? So there is no error happen. Now, if I run what is it? arm-ttk again, then oops, oh, it's okay. Hang on, is it still? Did I write that thing? Hang on. Okay. So yeah, let me show you another example for this. So if I use, instead of this, core windows.net, something like this. So the storage account has the suffix of core.windows.net, right? So if I use this, and it should hang on. So yeah, Bicep file is generated okay, but if I run this, then see here. So deployment template must not contain a hard-coded URI. So these kind of things. So the we usually use this approach, but the general best approach is not to use this hard-coded value, but instead we use this kind of the ARM template function goes in environment the suffix value, something like that. And there are many things. So server farm ID should be like the generated ID, not hard-coded one, something like that. So by doing so, the ARM template is tested against the arm-ttk. So if I change back to the environment suffix storage, then if I run this again, so yeah, every test goes past, right? So these kind of things, we can use the ARM template and arm-ttk. So what did we do today? So we generate Bicep file easily. Then with Bicep CLI, the Bicep file is converted into ARM template, and that ARM template is tested against arm-ttk. And now that ARM template is ready to use, and you can put this on your favorite, the preferred, the CI/CD pipeline. So Bicep and arm-ttk are integrated with CI/CD pipeline. So I'm pretty sure the AGL is using the Azure DevOps. And both the Bicep CLI and arm-ttk is provided, the community provide the GitHub actions, such as like a Bicep build, an ARM template toolkit, or something like this. So you can find those links and have a look at that. Unfortunately, Azure DevOps Pipelines is also supported by community. They only provide us with the arm-ttk actions only. So if you want to integrate your Bicep related things, you probably need to install the Bicep CLI within the pipeline, doing some like the running the bash shell command or the PowerShell command.
Okay, so every build, just in Saurav,
Yep.
so yeah, quick one. So with every build, are you saying if we would need to use Azure Bicep, then we would have to install Azure Bicep on each of the hosted agents if you are running it in Azure DevOps?
If you are using hosted agent, the hosted runner, then yeah, unfortunately the Bicep CLI is, I don't think is already in there, so you should install it.
Okay, but can't we select an agent which already has this updated, like that? That's not there yet.
So if there is if you are using the private hosted runner, then you can install it and use it, and you don't need to install it again. And also, if once the Bicep is production ready, I think then the hosted runner will have the Bicep CLI already installed. Cool. Yeah, and yeah, this is my actually demo and talk. So yeah, so from now, so we can have a chat. So yeah, if you have any questions,
I'll let the group answer that. Suman, Brata, Papun, Aman. Any questions on this?
No, all good so far. Yeah, so that's the same question I had. So if we are using that same hosted agent, so we need to install it every time. So yeah, that's. So what's the approx time when it will be live? Is there any ETA or any estimated time?
Good question. So what the ARM template, the ARM team says that within the roadmap, they are planning to be production ready late this year, end of this year, or early next year.
Okay.
So before that, yeah, so play around with this, as I said.
Yeah.
Don't use for production use, but after the version 03 is released, then you can now use. And then so while you are using it, and if you find something, if you want to suggest or something, then the pylon issue on the Azure the GitHub repo. So then they are very active on fixing it.
And is there any plan to convert the ARM to Biceps by that time? Any conversion tool to convert?
So you mean ARM template to Bicep?
Yep.
That will be provided with the after version 03.
Okay.
Because a lot of our infrastructure code is already established through ARM templates, and Azure Bicep kind of seems the next logical evolution to ARM templates, and we would like to leverage that. But we need to have a way or a path where we can convert our existing templates into Bicep files, which can be embedded into our repo GitHub.
Yeah, their plan is also that I didn't show the demo today, but it's very easy for the modularization. So I put everything in one Bicep file here, like the storage account and the consumption plan and the function app instance. But you can actually separate these 3 resources in each Bicep file. Then one, like Terraform. So one, the master, the Bicep file can refer these modularized resources. But that's different from the nested template. So be cautious of that. And also, they are by using this kind of modular approach, they will have the capability to directly infer the existing ARM template. So you don't have to convert existing ARM template into Bicep file then.
Cool. Sorry, Aman, you were asking something?
Yeah, my mouse is going crazy. When I click on mute, it unmute me. So it's about the CI/CD integration. For example, right now we have parameters in JSON file, and we do the replacement. But since Bicep is a totally different file format, right? So how that is Azure DevOps support that, or do we have a custom extension for the variable replacement?
So Bicep doesn't do any deployment related thing.
No, I mean, you refer to the Biceps file to do the deployment, right? So like building the things.
So let me, sorry, finish your words first.
So what I'm saying is, like, in the parameters, we usually refer to the variables sometimes. And, Biceps needs every parameters to be filled in, right, before building things.
No. So you want to provide the parameter JSON file?
Yeah, sort of things like a variable replacement for that.
So at this stage, the Bicep only takes care of ARM template, not the parameter.json. So and the Bicep doesn't do any deployment related actions. So the typical process of using Bicep and the resource deployment to Azure is that you write the code on the Bicep, and within the CI/CD pipeline, you compile it to the ARM template. Then run the Azure CLI or PowerShell to deploy the ARM template, to run the ARM template to deploy the resources. And in that, during that time, you probably need to write. You still need your own parameter file, the Azure deploy.parameters.json or something like that. Does that answer your question?
Yeah, but the challenge is if I change my Azure Bicep file and generate a new template, then I have to separately change my parameter file to match the new template, right?
That's correct. Yeah.
It won't be automatically done if I say I change the Bicep with a new, say a new step or a new component and add some kind of parameter in the Bicep. It converts into the template file, but again, I need to add those parameters if I want those parameters to be published from a parameter.json.
That's correct.
That has to be separately added.
Yep. So parameters.json file is not handled by Bicep yet, but at some stage they will be supported.
Okay, it would be. It is something that's in the roadmap, would be supported.
But we still need to write our own parameters.json file anyway. So without Bicep, when we are writing ARM template, and if there is a parameter changes, that has to be manually applied to the parameters.json file anyway.
Yeah. So the plan, what I'm looking into is a singular place. Like if I'm writing it in Bicep, then Bicep should provide me a editor in way so that I can write my parameters as well. So when I compile them, so my template and parameter files are generated through Bicep, and then I run it.
Yeah, that's a good question actually. I don't have an answer for that yet, but if you And I think it's a good idea. You can the pylon issue on there, and so that your idea can be reflected for the next release.
Yeah. There's another question which I have, Justin. It's related to like again, Azure Biceps is leveraging the Azure API behind to build the ARM templates, right? And so how frequent are we updating the Azure Biceps? Like so you have a new Azure resource spinning up, so you will have the support available in ARM templates quite fast. So and since Azure Biceps is more like a boilerplate sort of thing above the Azure API, so how frequently it will be updated, like the API version which support that new resource for which ARM template is already there?
So Bicep, as I said, so Bicep doesn't do anything. So if ARM template supports the newest API version, then Bicep automatically supports it.
Okay.
So it's used the same ARM template API versions, right?
Yes. Yes.
Okay. Yeah.
So keep this in mind. Bicep doesn't do any deployment. So ARM template does the deployment. So if you are specifying a specific API version of a specific resource as a resource, then you can use it through ARM template, which means you can also use the same API version within the Bicep.
Yeah.
So any other questions? Papun, you have been awfully quiet. Papun, you're on mute if you're saying something.
No, all good, sir, from my end. Yeah.
Cool.
Basically, we are excited like for this Azure Bicep to come in. It would gives us the modality. It will basically gives us the modularity around what we do. So yeah.
Yep. So make sure that the Bicep currently doesn't support the looping, the copy and indexing thing, and condition thing. So other than that, yeah, it's fairly okay to use.
Thanks, Justin, for
Yep,
this.
no problem. So yeah, I think that's it for now for this session. So I will share the recording
that would be great.
and what is it, the slide deck after this session.
Cool. Thanks, Lauren, and I know Damien can't be here for setting this up. I probably would probably will try to play around with this. This is something that is in our backlog to look into, and once the production version is released, would be happy to leverage it in for our applications.
Sure. So if you have any questions around Bicep, and then please reach out to either Lauren or Damien for the further discussion. And this is the GitHub repository for Bicep and arm-ttk. And the last one is my blog post about the Bicep thing. So please have a look.
Yeah.
Yeah, sure. Definitely.
Can I put these links in the chat, Justin?
Oh, sure.
That would be good.
Oops.
So, Saurav, do you think this is useful for what you're doing? Makes it easier?
Yes, Lauren, it does. And so the ARM template library that we had built for a lot of the assets that we have in PaaS, I think this kind of is the logical evolution for that, because it's easier to maintain, easier to manage rather than clunky JSON files. So yeah.
Yeah. We also need to have a look like how exactly Azure Biceps will have the complicated ARM template logics which we have. Definitely not the condition. We know not conditions are not supported, but still there are some configurations which we have which are quite complicated in ARM templates. Definitely we'll have a look like how exactly it's going to ease down those things.
And Justin, you said by the December or January, it might be going GA.
Not GA, and the production ready.
Production ready. What does that mean?
Yeah, so generally available and production ready is different because at this stage there is no SLA. But
Okay.
after version 03, yeah, the ARM template team actively supports the customer case. But that doesn't also mean it's GA. Yeah. That's what they say. I don't know exactly what they mean.
Maybe an action item on Loring to find out exactly
the best
what
non-answer I've heard. So we maybe the beginning of next year we can expect to be able to use it for production. Okay.
Sounds good.
So Surav, yeah, I guess take that for whatever it means. But yeah, I think Surav, I think if you want to start playing with it now or testing it, it's still alpha version, so
yeah, we will do that. I think this definitely has potential, at least in the scenarios that we use, given we haven't we don't use Terraform, we want to stay Azure native. So that kind of helps us evolve in the right direction.
That's right. So when you go to the GitHub repository for Bicep, they will have the entire roadmap, including when the next release or something like that. So definitely have a look.
Yeah.
All right. So all
Thanks,
good.
everyone. Yep.
Yep.
I think that was awesome.
All right.
Thanks, Justin.
Thanks, Justin.
Loring, good.
Thanks,
Justin.
Thanks, everyone.